Boyle's law says that the pressure on a confined gas times its volume is equal to a constant if the temperature remains constant. If we were to plot these two variables, volume versus pressure, we would see that when the pressure is low, the volume is very high. And when the pressure is very large, the volume is very low. There's an inverse relationship here between pressure and volume. As one gets bigger, the other gets smaller. A prettier graph is if we graph volume versus 1 over the pressure, and that turns out to be a nice straight line. Charles' law says that the quotient, volume of the gas divided by its temperature, is equal to a constant when the pressure is constant. If we were to graph volume and temperature, we would see a nice straight line. It is important whenever we're using the temperature in an equation in the gas laws that we use the temperature in Kelvin. So I've put a double asterisk by that. Maybe instead of a double asterisk, you want to put a money symbol because that'll draw your attention to it. Oh, money, wait, oh, no, temperature in Kelvin. Okay, he tricked me into looking at that again. You should know that 0 Kelvin is equal to negative 273 degrees Celsius. If you want to put the 0.15 in there, you can, but negative 273 degrees Celsius. Of course, there is no such thing as a negative Kelvin temperature. So if you calculate a temperature and it comes out to be negative 58 Kelvin, you're doing it wrong. There can be negative Celsius, but there's nothing more negative in Celsius than negative 273.15. Gay-Lussac's law says that the pressure divided by the temperature, again most conveniently in Kelvin, is a constant when the volume is constant. If we were to graph pressure and temperature, we would see a nice straight line like so. On this slide we have at the top Avogadro's hypothesis, and down near the bottom we have Avogadro's law. A law is a mathematical relationship that we observe. We don't necessarily have an explanation for it, but we observe it. A hypothesis is a prediction. It's an educated, testable guess. Avogadro's hypothesis, you can read it here for yourself, equal volumes of gas at the same temperature and pressure have the same number of particles. There's a portrait of Avogadro. I'm not sure if the painter of this portrait actually got paid or not. Either he didn't do a very good job or Avogadro was rather ugly. In any case, for example, 22.4 liters of any gas at standard temperature and pressure contains 6.02 times 10 to the 23rd particles. You might have heard that if you've taken a first-year chemistry course already. That's Avogadro's hypothesis. A certain volume of any gas at the same temperature and pressure have the same number of particles. Now, Avogadro's law says that when the pressure and temperature are constant, the volume of a gas is directly proportional to the number of moles of gas. In other words, the volume is proportional to N, where N is the number of moles of gas. Don't confuse Amedeo Avogadro with Amedeo Avocado, who, in a strange twist of fate, was actually born 100 years to the day after Avogadro, and actually died 100 years to the day after Avogadro. It's simply weird. Let's review. Boyle's law shows us mathematically that as pressure goes up, volume goes down, and vice versa. Charles's law shows us mathematically that as temperature goes up or down, volume also goes up or down. Gay-Lussac's law shows us mathematically that as temperature goes up or down, pressure also goes up or down. Now, knowing the names Boyle's law, Charles's law, Gay-Lussac's law, in my mind is not so important. What is important is to understand conceptually what happens when, say, the pressure of a gas decreases. If the pressure on a gas is decreased, its volume is going to go up. If the pressure on a gas is increased, its volume is going to be smaller. if the temperature of a gas goes up, what tends to happen to its volume? Well, it's going to go up. If the temperature of a gas goes up, what happens to the pressure that it tends to exert? Well, it's going to go up. Those conceptual ideas you must understand. I would say it's less important to know the actual names of the laws. Let's move on to point 4. Avogadro's hypothesis says that equal volumes of gas at the same temperature and pressure have the same number of particles. This is due to the volume of the particles themselves being almost negligible compared to the volume of the whole sample. And finally, Avogadro's law says that volume is directly proportional to number of moles.